I want to welcome our next guest, Scott, who is the co-founder and CISO at Stackhawk, which is an amazing company. You all should check it out. We'll get more into that in a little bit, though. But welcome to the Big Fix, Scott.
Big Fix in CODE.
Yeah.
That was what happened at lunch. That happened at lunch.
Hey,
I love
thanks
it.
for having me.
I'm super stoked to be here.
Thank you for coming. So the topic of this part of the segment is how you can best prioritize and fix vulnerabilities. But before we get into that, I think the viewers want to hear a little bit more about you, Scott, as the person. So tell us a little bit about your background and what are you most into?
Yeah, totally. I'm going to start with a joke. You ready? Horse walks in. No, horse. Oh, I screwed it up. Here we go. A racehorse clicks into a live stream. And the live stream host says, "Hey, racehorse, how did you get here?" And the racehorse says, "Trackpad." Yeah.
Nice. Good one.
Tomas is laughing somewhere. Anyway, my background is in information security, application security, infrastructure security, all that good stuff. I've done 10 years at like GoDaddy, a couple years at SendGrid as a SO there. Application security is a core piece of what I usually do, and was always out there looking for great tools to help developers fix stuff. Great segue into Big Fix. And we just couldn't find a great one for DAST ever. And so that's what we set out to do at Stackhawk, was make a DAST tool that's super easy to use, super easy to help you find and fix vulnerabilities, and especially prioritize fixing vulnerabilities. And that's usually one of the hard things to do in AppSec land, because you're kind of going, wow, there's a huge slate of stuff here. Which things should I fix first?
Absolutely. I mean, maybe we can get into this, but first, maybe you can talk about the answer to a question that I personally have, which is, if you're somewhat new to the security space, let's say you're a developer, you've been building things for a while, you have a decent understanding of security, which I think, or a decent understanding of development, which I would say most of our audience does, but you're not super familiar with fixing vulnerabilities, all the things that go into that. So if you're just getting into something like this, maybe you could quickly speak to how many vulnerabilities is it even standard and common for someone to have, whether, let's say, it's a hobby project you're working on, all the way up to a massive enterprise application that lots of people work on. Because obviously prioritization is important, but if you have only one or two vulnerabilities on average, like, is it even important to prioritize them? So maybe you could just start talking about that. Like, what is common for people to see when they actually start tracking security and vulnerabilities in their applications?
Yeah, I think common, to me, prioritizing this stuff based on criticality is really important. And as a developer, not understanding necessarily maybe what each of these vulnerabilities is, but understanding criticality of the vulnerabilities just by categorization to start with is super important. So obviously, if you get a brand new list and your thing says I got 5, or your thing says I got 500, I would always recommend just kind of walking through the highs first. Because if you can get through the highs, you're going to have a good understanding of what you're doing. And that might give you an indication of like, oh, maybe I should go take care of these mediums too. It's not in great shape. Or, you know what, this is actually a pretty good place for me to be in. I'm going to work on these mediums as they come up, or as I can get to them, or whatever that is. But usually those highs are pretty important.
When you're talking about highs, what do you mean exactly? Are you talking about the severity of the vulnerability, or what?
Yeah, I'm talking about the severity of the severity of the vulnerability. And so we're talking about things like command injection, or cross-site scripting, or Sql injection, like an attacker, an outside person being able to make your code do something it's not supposed to do. Those are usually the most severe kinds of things that can happen. And they're most often prioritized as high or critical, or some other version of OMG, really important to look at now. And so those are the things that I usually say, take a look at those. If you can understand what's going on there and what they mean, you're in really good shape, because they're usually fairly self-explanatory. They usually point you at a thing that is pretty scary, possibly, and typically fairly easy to fix. We'll talk about some of that today.
So if you're a developer and you're using a tool like Snyk or Stackhawk to help find and fix these vulnerabilities, like, where are those severities coming from? So who's the one behind the scenes saying, hey, this particular vulnerability that we've identified in your code base is high severity and you need to focus on this? Like, where does all that information come from?
Yeah, that's the best part, because that's where security pros do a really good job. Security pros feeding that information into these tools and frameworks to be able to say, this is actually severe or critical or high or whatever that is. So that you can then go, okay, I should probably pay attention to that and not have to be able to look at every one of them with no categorization, no priority, no severity, and then go, which one should I fix? Because, that's not our job. That's not a developer's job, is to be able to go, which ones are the most important? I'm trying to deliver value for the company or for my open source project or whatever that is. And getting code out the door that's high quality, fast, secure is really important. But being able to, if you get a performance report that says everything takes 0.2 seconds except for this one thing that takes 0.3, are you going to prioritize fixing that over a feature? Or, those kinds of things. Being able to help prioritize those things is important.
Now, would you also say that's sort of the case across the board, or would you ever recommend people go about it in a different order in terms of prioritization?
I think it depends on where you work, what you're doing, what kind of information you're handling. If you're handling credit card information, maybe you want to take care of all of those things. But if you're if you're not handling that kind of information, or it's less sensitive, or you're not subject to regulation, it kind of depends on what, at that point, maybe even what interests you, what problems were these things are raising that are interesting to take a look at and then fix.
Absolutely. I think it makes a ton of sense. Also, for what it's worth, I was actually on the Big Fix live stream yesterday, and I think it was MongoDB that was showcasing some of their open source projects and saying, hey, we'd love security help on these things. I actually went in on the live stream and was running some Snyk stuff on there and sent them a PR to fix a really minor thing. And there's a ton of other things as well. But I think, in some cases, it's easy to get started with the minor things where maybe you can automatically fix it by updating some old dependencies or something like that. It just feels really good to get that momentum going.
Totally. Yeah. And we're going to talk about that today too. But yeah, some of those things are just like easy pickings, right? You just go in there and you tweak an application setting, or you tweak a header or whatever that is. Those are super easy to fix. So, taking a look at them is also valuable. Making sure you cover those criticals, highs, pretty important.
Awesome. So getting into the next part of this, I remember you emailed me and said you had a project that you built specifically for this live stream. Do you want to share your screen and sort of talk people through it and maybe give them a taste of how they can better prioritize and fix these vulns?
Yeah, let's do it. All right.
Here we go.
Out here on GitHub/Gerlach. Hey, that's me. Big Fix repo. This is a public repo. You can pull this down and play along, or fork it and submit PRs. All that stuff is going to be awesome. I've actually got that running in a Docker container, in IntelliJ over here. So here is actually my IntelliJ console for this Big Fix project. I also ran Snyk code scanner and the open source scanner and the quality scanner and the entire scanner suite against this.
Scan everything. I like
scan all the things. And you can see it has problems, and it has a lot of Sql injection problems. So we're gonna walk through that. We're gonna fix that. But it has some other problems that the Snyk code scanner didn't find, because the Snyk code scanner doesn't look at the running app. And that's where the Stackhawk part of DAST, Dynamic Application Security, takes a look at and can help, because we're actually looking at the running application and what it's doing and information it's exposing. So first, I want to take a look at the Snyk results here, which is...
And hold on, Scott, let me pause you real quick. We have a few requests to blow up that font size, if you don't mind.
Well, I can't make the Snyk part bigger.
Okay.
I can make this bigger.
There we go.
I can't make this bigger.
That is all right.
Trust me, there's Sql injection things in here. All right. I'll make this big so everyone can see it when we get there. But what I did do was run a Stackhawk scan against this. Again, both of these tools are free to use. So Snyk has a free account. Stackhawk has a free account. You can get started with both of these things for free at both of our websites. But what I did was run a Stackhawk scan against this. Again, this is against the running app. So here's the little app, right? And now it's big and people can see it. And it has very little functionality. And some of that is like searching in a database and all that good stuff. So I set up a Stackhawk scan to run against this. And here's the results that I got. from the Stackhawk Scan. So I have the SQL injection. Hey, we're talking about prioritization here. There's a SQL injection over here. There's a SQL injection over here. Cross-site request forgery issue over here. Cross-site request forgery over here. These problems are starting to line up. Seems like we got stuff to work on here. But I want to point out that there's a couple other things in here that we didn't find that might also be important. And that's this cross-site scripting guy. So this app seems to have a cross-site scripting problem in it, which looks pretty legit to me. We'll try that out. And then there's also this information leak that I want to check into, because I think that's interesting too. And you can't necessarily discover that with static code analysis. So we're going to dig into both of those. First, we're going to hit that SQL injection because it's important. So in the Stackhawk console, we see the SQL injection. I'm making fonts bigger. We can see this is on the search path. We can see the request that got put into the application and the response that came out. So we've got some kind of SQL exception happening here. I can actually replay this attack. So now being able to recreate this problem from external is super interesting and important, because we want to be able to walk through this. I'm not going to walk through this. I got a half an hour. I'm going to go quick. Here we go. So the other thing that's interesting here is the Snyk side of this says we got SQL injection problem in all these different controllers. And if you look, I know you can't see it, it's small, but I'm gonna try to help here. It's middle of the screen. If you look at each of these things, you can see that this part of it is starting to say the same thing. So the search service seems to have a problem, and especially this execute query. Let's go look at that. Now, I may or may not have cheated a little bit here in the for time, but the query that we're running against the database is this guy right here. So you can see we're actually maybe doing this the wrong way. Over here, we're just embedding search text into this SQL query. That's exactly how SQL injection happens. So if you're not new, or if you're new to how SQL statements work in Java or any other language, and you don't understand, or you miss this whole parameterized query thing or input validation from the client, you could end up in this position, right? And luckily, both of these tools are telling us about this thing. So this thing is saying, hey, don't do that, because what you're doing is giving attackers the ability to control what's happening in the database. The righter way to do this, and so we're just going to cheat a little bit. Again, look, man, it's a live demo. Okay, I cheat a little bit. Is that cool with you, Randall?
Hey, I'm all for it.
All right,
in
cool.
security, there are no rules.
There are no rules. I mean, there's totally rules. But so now here's the righter way to do this, right? So we have the same query statement, but this question mark is different than what was going on up here. So this question mark is how we're doing parameterized queries in Java. And then we are doing a prepared statement, and then we're sticking this search text into where this question mark goes with this statement.setString. So in Java, this is how we're actually setting up the parameterized query, and then we're executing that query. So I think I've got this fixed.
So this is basically going to ensure that when people are sending data into this this route that you've created, that it's going to be sanitized first before it's actually executed by the SQL engine, right?
That's right. So what's happening here is it's actually encoding this properly when it sticks it into the SQL statement. It's escaping it, encoding it so that the SQL statement can't get overridden. You can't escape out of what the SQL statement is. And in fact, it's going to search for exactly what you put in here, and you can't get yourself out of the SQL statement.
Love it.
Awesome. So I'm going to stop this little app that I have running here, and I'm going to rerun it. And I'm going to do two things.
So now, since you fixed the issue, ideally it should no longer be detected, right? You should have
should no longer be
this vulnerability.
That's right. So we're going to go back, and we're going to throw away our Snyk results, and we're going to rerun our Snyk results, or Snyk scan. And then the other thing we're going to do is we're going to do a hawk scan against this. So as long as I can type the thing, I know you can't see it. Believe me, we're running a hawk scan. Wait, this one I can blow. Yeah, this one I can blow up.
Oh, there we go.
Okay, so now I'm running both tools again, right? I'm running both the Stackhawk Scanner and the Snyk scanner. And those results will show up here shortly. Here is my Snyk output. So you can see I no longer have a SQL injection issue popping up all over in here. So I think we fixed that. I'm validating that with that Stackhawk scan in the platform. In the Stackhawk platform, we can see that this scan is running, and here's all the tests we're doing against it. It's in the middle of doing SQL injection, so we should see some results here real quick. In the meantime, let's take a look at that other thing that happened there, that SQL or cross-site scripting. So this is also on the search path. It looks like we can inject this particular string into our little search query. So let's try it. Let's, we're a user, and our password is dots. So if we actually, oops, not that one, this one, copy. All right, here we go. So that's exactly what the Stackhawk scanner did, and that looks like cross-site scripting to me.
Nice.
So here's why these two tools are very important and important together, right? That very first one we saw in both tools. The Snyk side pointed us at the code to fix. We can validate that fix is gone with both tools. That's super good. But now we found a cross-site scripting in here that is not found in the other side. So we can actually recreate this, test it, and know where that lives. That actually lives out here in Java templates. Where did you go? Templates. All right. I cheat on this one too. Okay. I'm a big cheater. You guys can call me a cheater. It's cool. Also, if you have any questions, drop them in chats because we'd love to answer them. But in Timeleaf, so this application is using Timeleaf. Utext is unescaped text. Text is escaped text. That is a super easy mistake to make. And boom, cross-site scripting. And what cross-site scripting is an attacker can inject JavaScript into your application and get other people to do actions with that same JavaScript. So steal session cookies, steal information from your browser, steal, all kinds of stuff that they can do with that. Bad. So here we go. Fixed. I have now fixed this cross-site scripting thing, which we can also validate once again. My last scan just finished. So let's look at this. Again, SQL injection gone from both tools now. Snyk and Stackhawk have said SQL injection's gone. So that's
beautiful.
Good. Yep.
Also, real quick about the cross-site scripting stuff. If I'm not sure what your opinion on this is, but seems like cross-site scripting pops up in way more places than people realize. Like
what's
really
funny,
clear, right?
Yeah, what's funny, Randall, is theoretically frameworks and new frameworks and all kinds of new languages have prevented these things from happening if you use them the right way. Yep. Right? As you just saw, if you use them the wrong way or accidentally use them the wrong way, you can put those vulnerabilities right back in there, right? So a lot of data object models in new language frameworks, a lot of escaping functions in new language frameworks. Usually there's a way to do it the wrong way. And if you're not an experienced dev or you haven't run some of these tools and found some of these things, you can make these mistakes. And being able to say, I haven't made these mistakes, feels good to me.
I've been talking about this for years, but it's really interesting to see it play out in the real world, I think, because oftentimes, cross-site scripting vulnerabilities get introduced through tools that you may not even directly control, maybe you're using some NPM package and you import a JavaScript library into the front end and there's a vulnerability there. That might mean someone can run any JavaScript code they want on your site, which is super scary.
Yeah, again, we're talking about prioritization here mostly. So when you do that, when you have an NPM package and you've included it and you're using it in a way that can be exploited, that's where DAST is really handy, because DAST can go through there and potentially find that and help you prioritize it. But sometimes you haven't used it in a way that's exploitable. And now the Snyk tool or some other tool is going, hey, you got to upgrade this thing. And you're like, oh man, I'm so busy. But that DAST scanner can potentially go, actually, you're not vulnerable to this. Same thing with Log4j issues, those kinds of things that are coming up and continue to come up, and probably, they're not going to stop, can help you. It's a great question. So anyway, that's kind of how I think about putting both of these tools together and using them.
For Potato Scream, they're asking, hey, speaking of NPM packages, does Stackhawk detect exploits and dependencies? I have no idea. You seem like the expert on the topic.
Yeah.
What do you think?
So Stackhawk can detect exploits and dependencies if, okay, first of all, DAST. Theoretically, you can use DAST to make CVEs for NPM dependencies, right? So
and actually, wait, Scott, this
Hit me.
is another really good thing. Sorry to keep interrupting, but
No.
why don't we talk about the difference between SAST and DAST real quick, just
Let's
in
do
human
it.
terms for people that are new.
You
So
bet.
oh my God, SAST is all about testing your application statically. So looking at the
That's
source
right.
code, analyzing it, trying to find issues, right?
Looking at this stuff.
And what is DAST?
So DAST is actually dynamic application security testing. So where SAST is looking at exactly what we're looking at here, right? We're looking at our search service and all of this code. We're looking at this. DAST is looking at this version of it. So this is actually the running code. So it's looking at this like an external person would, or a threat actor, or whoever, and trying to test all these inputs and outputs for valid handling of bad or threat data, right? So in this particular case, we're doing this cross-site scripting thing, right? You saw before it was popping a cross-site scripting. That now it's not, because we fixed it. But the only way we could detect that in this particular case was testing the running application, because it's hard to know if in this template that text is supposed to be unescaped or is supposed to be escaped, right? In a SAST land. So SAST is looking at this part of an application. That's the static code, the stuff that you write. DAST is looking at this running application. So when you compile it, make artifacts, run that actual piece of code, that's what DAST is looking at.
So how is a tool like Stackhawk actually doing the DAST scanning? So are you actually making HTTP requests to
You betcha.
a given URL that you're monitoring in the Stackhawk app, basically?
That's right.
Or?
So the Stackhawk Scanner, let's see, I have the terminal output here. This is actually a scan that I ran this just on my local machine here. Started a Stackhawk scan. It's went and crawled through this site, works with APIs, GraphQL, REST API, all that good stuff. Starts testing inputs and outputs, right? Starts sending malicious input. If the app responds incorrectly, it's going to throw an alert. So that's how that's working back and forth there. So the interesting thing is, you saw back in our search service, there's a bunch of logging going on here. So if I actually go back here to my run statements and make that big so people can see it, you can see all the stuff that Stackhawk is injecting. Oops, here we go. You can see all the stuff that Stackhawk is injecting into that search thing, which is then turning into SQL parameters. So lots of hibernate sequence, all kinds of interesting things that we're injecting in there. That was actually for me doing the SQL, the cross-site scripting fix. Here we go. Yes and nope and no and yes and no. Sorry, I lost it. I lost it because I restarted it. Anyway, you know what we can do? We can do this while we continue to chat.
Yeah, I mean, that looks beautiful. And I think one of the benefits of this, of course, is what we were talking about earlier. If you are suffering from issues like cross-site scripting attacks that maybe aren't in your first party code, but in one of the dependencies, like this is going to discover that, right? Because as you're crawling the front end, it's going to look at those dependencies and sort of make those or raise those issues.
That's right. Hopefully we can find those things. Sometimes they're buried and they're a little difficult to get to, but hopefully we can find those things and help you prioritize what NPM packages you got to upgrade, because they're discoverable and exploitable.
Yeah, absolutely. And I mean, having a tool like that on hand, I think, is critical, especially if you're doing a lot of web development and you don't just want to look at dependencies, you want to look at the real world inputs and fuzz them and all the other things too. It's great.
So here's all that SQL injection attack that's going on, and then continuing, like the scanner is trying to throw a bunch of stuff at that search form, turn that into SQL statements. Lots of cool things. Anyway, I know we still got like 3 minutes.
Yeah, we got a couple minutes left,
All
but
right, cool.
Another thing I think would be great too. So if people are watching the stream, never heard of Stackhawk before this, what are some things you'd recommend they do to get started implementing like dynamic application security testing into their toolkit? Like, where should they go? What should they do? What's your recommendation?
Well, obviously, first of all, go to stackhawk.com, click the sign up now button, get yourself a Stackhawk account. Stackhawk is 14-day free trial, no obligations, free account after that, to be used on one application. So if you're working on some kind, you know what, I was going to try to do my good buddy Couch Potato in this little demo. Couldn't quite get us there. But Couch Potato is a great open source project that, we could test with Dast. We could test that with SAST. With SAST. We could find some interesting stuff. We could have maybe made a PR to that thing and made that work. Maybe in a different session, the smaller or bigger fix, we'll do that there as well.
Maybe that'll be coming in 2023, the bigger fix.
Bigger fix.
Next year's event. We'll see. I like that. That looks great.
Awesome.
All right. Scott, thank you so much, my friend. Any final words you want to impart to our viewers at home?
Yeah. First of all, thank you to Randall, Snyk, the whole crew for inviting me to participate in the big fix. I'm going to push this PR. That number is going to go down because we scanned it as part of the big fix. Awesome. So that number will go down. If anyone has any questions, hit me up at @Gerlach on Twitter. I think that's it. Thank you so much for having me.
Thanks for being here. And with that, we'll say goodbye to Scott.